All right, moving on to the sixth type here. We've actually seen these before. If you've seen x to the 1/2, x to the 1/3, 1/4, we know what the rational exponents mean, and that means radicals. So these are all radical functions. Now I kind of added a little bit to the blue one because the graph was kind of incomplete. A blue one, you can actually plug in negative numbers into um, a third root because you can get negative numbers out, right? So just like remember, if we had the third root of 8, which is 8 to the 1/3, we're going to get 2. But if we have the third root of -8, that's just -2, right? No imaginary numbers, no nothing. So you can input negative numbers and you can actually get negative numbers out. So you kind of have like this S curve for anything that's going to end up being an odd index, because odd indexes you can actually get negative numbers out and you can put negative numbers in. Even number indexes like square roots and fourth roots, right, that's going to be a problem because if the square root of 64, great, that's 8. Square root of -64 is 8i. So we can't do that. So it's only going to work for indexes that are odd numbers where we can get negative numbers. We can put them in and we can also get them out. And that's kind of what I'm basically showing in terms of this. So, x to the 1/4 would have an even index, so that's only going to be this red graph. Same thing with the x to the 1/2. But an x to the 1/3, right, you're going to get this S shape because you're going to be able to plug in negatives just like you would positives. So on yours, you can kind of pick one of these and then just draw it on your graph and give it a domain and range. But again, keeping in mind, the index is very important. If the index is an even number, you have a set domain and range. However, if the index is an odd number, you will have a different set domain and range.